Okay, now I'm going to share my screen. Okay, make sure you type your name in the chat box to for your attendance. Okay, we continue to talk about correlation and copulas. Okay, today we talk about how to do a GARCH one-on-one model to estimate correlation. Last time we talked about the equally weighted moving average. So we have two different ways to measure the dynamic correlation or covariance. The one way is to exponential weighted moving average. So we using the first formula for exponential weighted moving average. You have lambda, which is the parameter you need to estimate. So the current variance, covariance, is equal to lambda times the covariance of a previous period, in the previous period, times 1 minus lambda times, this is the x n minus 1, okay, x n minus 1 is the return of a previous period. Remember last time we talked about let me show you the question we have last time. So we did this before and on Monday. So you can see the first, you get a 2 series of data. I use Australian dollar and a euro. So we have a 2 different series of data set. Or you can use different stocks with 2 stocks. This is the return, the first. You wanted to, based on the adjusted closing price, you calculate return. Okay, I use long return. Okay, remember, so you can use a long return, or you can do equal to the price of most recent minus the price of a previous period and divided by the previous period. So this way you can calculate return. Also, you can do the long return, so either way, okay? So that's how you get the return. Do the return for both series, and then you calculate the product of these two returns of these two. It is going to be this, okay, D3 equal to the D3 times E3. So you have the, this is called covariance of return. So the covariance of return, and this is, you square that return. Okay, remember you square the return. This is called variance of this stock A. So that's going to be variance. And this is the square of the return is variance. So variance, variance, covariance. Remember, so when you wanted to have correlation, so you know the variance and covariance, how you get return of the correlation. Okay, so this is how you calculate the correlation. So the correlation can be written as the covariance between these two and divided by the standard deviation. The standard deviation basically is a square root, okay, the square root of the variance of the first asset and the square root of the variance of the second, right? That's the correlation. Okay, so now we wanted to know the covariance. Okay, the covariance, because we start with the first one, which is the covariance between two assets using the same number we have covariance. Okay, but for the next one, okay, you need to know is that it's going to use that formula. So this is the formula we just show you here. Okay, exponentially weighted moving average. Okay, this is the formula. You have the lambda. You suppose you have a lambda right here. Okay, lambda times the covariance between of previous period. Okay, you look at this. Okay, this one. This is the covariance equal to the lambda, which is Q1. You put $sign. You wanted to fix that times I1. Okay, I3. Like 3 is previous period covariance, and plus 1 minus lambda. Okay, you have said the 1 minus lambda times, okay, times the return, okay, the product of the return of the two assets in previous period. Okay, which one is this one, right? So it's going to times F3. F3 is the product of the return from previous period. So that's how you get equally weighted moving average. Okay, today we're gonna do is going to use a GARCH model. Okay, it's not going to be equally weighted moving average. So I'm going to show you how to do this using GARCH model. Okay, the same data set we used, same data set. Okay. So we're gonna do is right here. So we have the two series of data of the price, closing price of Australian dollar and euro. And this is the return. You calculate return for both assets. And you got the product of the return. And you square the return of A. And then you square the return of product B. Okay, asset B. Okay. Now what we need to do is going to do GARCH model. Okay, now we have to GARCH model. Do you remember how to do GARCH model? Okay, so the GARCH here. Okay, so here is the GARCH. The GARCH you're gonna do is you calculate the covariance. Okay, the covariance for the second time period is equal to omega plus beta, okay, times previous period covariance plus alpha times the product of the return of this two previous period assets. Okay, this is how you do GARCH model. Okay, now we do this. Okay, so we look at the GARCH model. So the first one, okay, we're using F3, which is just use the same covariance from the product of their return. And the second time period, we gotta have to use the formula. Okay, the formula, remember this is omega. Okay, this is omega, so we got here. So this is your omega, right, omega. So you put price F4 and you put $sign. That's your omega. And then you plus, okay, plus, delete that, plus. Okay, this is the beta, you press beta. So the beta, you press F4 to put $sign. Beta times this covariance of a previous period. Okay, you times this one, you times Okay, this one, previous period. And then you plus, okay, plus alpha. Okay, you have to get alpha here. Okay, this is alpha, and you put $sign times, okay, times the product of the return of these two assets. Okay, this is basically, that's F4, F3. Okay, now you complete your GARCH model for covariance estimation. So you follow that formula and then you drag all the way down. Okay, drag it all the way down to the bottom. Okay, so that's the covariance. Okay, estimate using GARCH 1-1 model. Okay, you do the same thing for asset A. Okay, the first we're using the squared return. The second we're gonna use the GARCH model. Okay, the GARCH model is going to be equal to omega. Okay, you fixed plus the beta times previous period variance, and then you plus alpha times, because alpha we need to fix it. Yeah, fix alpha, and times, okay, the previous, this is the alpha, right? We need to do this, okay, the squared return. Okay, for this asset, now we get this formula applied. You double click, you can see all the way down, get all the way down. Okay, this is a gamma. Okay, this is the variance of asset A, estimate by GARCH model. Okay, do the same thing for the variance of asset B. Okay, equal to alpha is omega, okay, plus your beta, okay, the beta times your previous period variance, and plus alpha, okay, 4, and times your previous period squared return. Okay, so that's for the variance of asset B, and then you double click, so you get all the variance. Okay, now, okay, so we do GARCH model. Remember, so you gotta have to estimate this alpha, omega, beta, and alpha. Okay, so we have the estimate number for this 3. So we're gonna do the log likelihood. Okay, so remember the log likelihood is ln. We do okay, remember, so I have estimate GARCH 1-1 model. Taking the logarithm, we see that this is equivalent to maximizing the sum of the long run variance, okay, long run variance minus the squared return, divided by the long run variance. Okay, you sum them up. Okay, we take a negative long run variance minus the squared return. Okay, so we have this one goes here. So because this is the long run variance of the J, okay, the J3, right, long run variance minus that the long run variance, the squared. Okay, this is the squared return. Okay, G3 squared return divided by the long run variance. Okay, so this is your log likelihood. And then you apply that formula all the way down. Okay, this is the long run variance. You estimate the likelihood. Okay, log likelihood, and you do the same thing. Okay, so this is going to be the ln of this long run variance. Okay, ln a long run variance. Okay, and minus that. This is the squared. Okay, the return divided by the long run variance minus long run variance. Okay, so you can get the log likelihood and you sum them up. Okay, let's we sum all this long run variance. So you sum them up. So you sum the long run variance. Okay. Log likelihood. So, and now you do solver. You solver, and then you wanted to maximize. You can maximize this. Okay, maximize by changing the alpha, omega, beta, and alpha. So you want to change that, and you're subject to the constraints. So you add those constraints. You want these numbers to be positive, but less than 1. So you have 0 and 1. Okay, so you can click on solver. Okay, so we have okay, let's see, we have okay, so we did that. Let's see, okay, so there is something wrong with that. Okay, so you just by changing the variable, okay, we have is you have I set this desert some square of this maximize by changing that value, and then you solve. You have a solver, so you can see you have a solver and you get this number. So the beta equal to 1 minus your omega minus alpha. So it's going to be, that's your estimate. Beta, omega, and alpha. So those are the how you do the estimation and using GARCH 1.1 model. Okay. So the correlation, when you wanted to see the correlation you have, the correlation is going to be, okay, the correlation, remember, is going to be the variance, covariance. We have the covariance divided by the square root of this variance, okay, A and B. So you have this covariance. So we have the name. So you can get the correlation based on the covariance of these two assets divided by the square root of S A and B. So you can get the correlation. Okay, get the correlation, and then you select all those numbers. You can see the correlation, and you have. So it's going to be insert a graph. So you can see the graph, and you can see this is how the correlation looks like. Okay. So the two assets, they correlate each other. As time goes, there is a dynamic change. It's not only one correlation. This is what we called dynamic changes of the correlation between two assets. Estimate by GARCH 1-1 model. Okay, now I'll go back to the assignment. Okay, so now we go back to your assignment, which is 11.6. Look at 11.6. Suppose that, okay, suppose that current daily volatility of the asset X and Y 1% and 1.2%. So you have the current daily volatility. And the price of the two assets was 30 and 40. And estimate coefficient of a correlation between the returns on two assets at this moment is 0.5, the correlation. Correlations and volatilities are updated using GARCH 1-1 model. So we're gonna use that GARCH model. The model parameters, alpha 0.04 and beta is 0.94. And this is omega 0.00001. Okay, we know that omega is very small typically. It's 0.0001. And for the volatility, okay, for the correlation, this omega is this one. And for volatility, omega is 0.00003. Okay, if the price of the two assets at close of the trading day is 31 and 51, how is the correlation estimate update? That's similar to the assignment. Okay, I'm going to use the GARCH 1-1 model. So we're using the GARCH model instead of the exponential weighted moving average. Okay, so let me let me get to the GARCH model. This is the question. Okay, we need to copy this to this question. Okay, the first we wanted to know is the covariance. Okay, the covariance of a previous period. So remember the two assets, they have volatility. The current daily volatility, this is which is a standard deviation. Okay, current volatility is a standard deviation. So we have this one. So you can use a standard deviation. Okay, get to the current volatility. You see, this is the 1% and this is 1.2%. So you have 1%, 1.2%, and then you times the correlation, you will get the current covariance. So the current covariance, okay. Okay, so current covariance, and you will get the current covariance. Okay, and then you have the most recent return. Okay, most recent return. So you have the most recent return. Okay, how you get the return? Because the price, you see, change from 30 to 31. $31 equals 31 minus 30 divided by 30. So the return is 1 divided by 30. Okay, this is from 50 to 51. So as a 51 minus 50 is going to be 0.02. Okay, that's the most recent return. So you have the return here. And the previous covariance, okay, we have the previous covariance, which is, okay, we can do it covariance. This is the numerator. Okay, remember your numerator. You calculate based on the correlation times the square root of this 2, right? Okay, the daily volatility. So you have 0.01, okay, 1%, and 1.2%, 0.012. So I want to make this bigger. Okay, so based on this formula, so you have this one. Okay, so the previous return, that's how you get this one. Okay, based on this formula, this is a this is 0.0006 is your numerator. Okay, is the because the new estimate of the covariance, okay, is going to be, this is a omega. Okay, remember, so for correlation, omega you use 0.1, okay, 0.001 plus, okay, what is your beta? So beta is 0.94, okay, beta times the previous covariance. The beta, this is a previous covariance, 0.06, beta times covariance is this part. And then you plus the alpha, which is 0.04 times, okay, the return. Okay, the return, 2 returns, we just estimate the new one is 0.033 and 0.21. So this is this part, alpha times the product of the return of the 2 assets. Okay, so now we're using this, basically this GARCH model, and you already estimate the current covariance. Okay, current covariance. Okay, next we do the new estimate of the variance of X. Okay, you want to do the variance of X. Okay, so variance of the X, so it's going to be, okay, now we do this again. So we wanted to move our GARCH model right here. Okay, so you can see the new estimate of variance of X. Okay, it's going to be, okay, omega. So remember, for the asset, okay, for the volatility, you use an omega is 0.003. Okay, the omega is 0.003. And this is your beta 0.04, okay, times the variance of previous period. Okay, the variance of previous period, remember this is a 1.2%. Okay, this is a 1.2%, okay, for the XY, for the X. And then you have the new volatility. Okay, the new one you just calculate 0.04. This is alpha. This is alpha times 0.003, right? 0.003. Okay, so you have the new volatility of the X. So you get a new volatility of X. Okay, remember, so you're gonna take the square root later on, because when you take the square root, okay, that's this number, you take the square root, that's the new estimate standard deviation, okay, new standard deviation of X. Okay, now we have the new estimate of the Y. Okay, the Y using this is omega times alpha times the return. Okay, this 2 is 0.0022. Okay, so you have alpha is the return times, okay, this 2 times the return alpha times the previous period return of these two assets. And then you plus beta, okay, the beta you have times previous period variance, okay, it's going to be 0.012, okay, 0.012. So you just got this number, remember? Okay, so now we have the new volatility of asset Y, and you take the square root. Okay, you take the square root. So the new estimated correlation between these two assets, okay, basically is going to be the new variance you estimate. Okay, this is the new covariance you estimate here. Okay, this is new covariance on the numerator and divided by the standard deviation of these two assets. So the standard deviation is going to be the square root of the variance. So you take this one and, okay, and this one, okay, this two. That's how you get this one. This is based on this formula. Okay, so that's how you get the correlation using GARCH 1.1 model to forecast the correlation. Okay. Okay, any questions?
No, sir.
Okay, very good. So we have the Copula and the measuring. I have this one. Okay, I have this one spreadsheet. I use this one right here. So okay, so I already create a spreadsheet and to how to generate a random sample from normal distribution. Okay, using this formula. Okay, you have first you generate a random sample. How you generate a random sample? Okay, this is the number you is using. This formula is called norms, inverse, and random. So you type in this formula right here. So you will generate a random number. Okay, so you have, for example, you just type in formula. How you generate random or normal distribution numbers. So you click on that, you will see you generate a normal distribution random number. So you just drag all the way down. That's how you get all those numbers, a random number. And you do the same thing for a second sample, okay? And so if you have two samples, you wanted to get the correlation between these two, okay? So what you're gonna do is that you can use this formula, okay? This is a random sample, and then you, okay, if you create a correlation, for example, 0.3, so you can use this, okay, generate the modified sample, which is the correlation, okay, times this number, sample 1, plus the sample 2, okay, times the square root of 1 minus that correlation. Okay, you can generate a sample, okay, which that using this formula, and this sample will have a correlation of 0.3 with your random sample. Okay, so this is very convenient when you know that you need a random sample, which is a fixed correlation with another sample. Okay, do you have any questions? Okay, if you don't have any questions, I'm gonna finish the meeting right here. See you next Monday. Okay, make sure you type your name in the chat box. Okay, good. Okay, so let me stop right here.